Hello, welcome to a special supplementary video from the Stat Cave, where we're going to talk about the logistics of making nice looking graphs. Now, in our regular lectures, we're going to talk about how we make figures look nice and aesthetically pleasing, if you will, using the basic functions that are provided and bundled within R. However, there is an entirely different sort of ecosystem that has been made for R that's very popular. It's called essentially the Ggplot world. It is part of the larger tidyverse that was pioneered and championed by Haley Wickham, and it is an entirely different way of creating graphs based on what's called the grammar of graphics, the GG in Ggplot. Now, this does take a whole different way of organizing and interpreting data, and so it can be a little more challenging, especially if you're just sort of getting up to speed on basic graphs. So that's why this is a supplemental video, that if you want to try this out, this is great. If not, you can, go back and not have to worry at all about this video at all. But there are a lot of people who swear by the Ggplot worldview, and a lot of very large organizations use Ggplot to make some pretty stunning looking graphs. So think about this as essentially going beyond. If you want to try it out, that's all well and good, but no one is going to think less of you or be graded less if you make figures in R. I struggle with the duality of using Ggplot for some things and regular base R for other things. So if you don't like this, isn't your cup of tea, don't sweat it. It's cool. So for this illustrative video, we're going to work again, just as we did in the before, with the Palmer's Penguins data set. Specifically, so we have already loaded the library Palmer Penguins. I've loaded the data, the Penguins data, and if you remember that this is a whole bunch of data that's being collected on morphometric information on 3 different species of penguins, Adelies, chintraps, and Gentoo penguins from different islands, and there's information on their bill length, their bill depth, body mass, sex, year, flipper length, all those kind of things. Now, in base R, we can create histograms like this, and this is not a particularly nice looking histogram, but you can make this histogram nice by sort of changing specific things. And you've noticed that I have specified that I'm using the data frame penguins, using the $sign to say calling out a specific column, bill depth. And because I don't want to plot all of my penguins, I just want to focus only the Adelie penguins. I mean, that makes more sense. But I'm using my square brackets to call out a subset of them. There's many different ways you can subset information. This is one of them. And here I'm now subsetting by looking in that data frame penguins, looking in the column species and saying only use those rows that match this condition, where the condition is it an Adelie penguin? And that gave us this sort of graph. And I could, make this look a nice looking graph, but I choose not to. Instead, I choose to, in this case, to try and see what the world of Ggplot does. So for that, I need to load up the library. It's called Ggplot. The package is called Ggplot2. It can get confusing. Now, as I said, this has a whole different sort of terminology and a way of viewing the world. It's based on the idea of modification and layers, adding on geoms, geometric elements onto a based piece of data. So the simplest kind of plot we could make uses this function Ggplot, and that's going to be the sort of our workhorse that does the vast majority of the functions. And in it, I'm saying we're going to be working initially with the penguins data set, and then I'm asking, okay, what are the element that we're particularly interested in sort of looking at, and in this case, I want to plot along the x-axis the bill depth, and then so that's essentially my Ggplot function, and then on top of that I'm going to add on what's called a geom. In this case, a geom histogram. There's lots of different geoms out there. We're going to sort of work through them in a series of these sort of videos that will come in the future. If I add geom histogram, you can see right off the bat that the look and feel of things of default in Ggplot looks quite different than in base R. And there's a lot of little elements there, and we're going to sort of work our way through all those different elements. And there's lots of really interesting books online, workbooks, guidebooks, things like that for getting even the smallest finicky details settled out. Now, you will see in my code here that I have some red warnings, but that doesn't mean that everything went terribly wrong. Sometimes it's just being sort of helpful, just doing it in a little more intense way than what we might like for this early in the morning. The first thing is, it says that in my geom histogram that I did not say how many bins I wanted to have. So by default, it has given me sort of 30 bins. And it says, pick a better value with bin width. So it's saying, here's what I've done. Maybe you can do better. The other sort of warning message, it says that it removed 2 rows containing non-finite values. And those mean essentially values that are not numbers. And we can see here, here's an NA value. So this is a penguin which was not measured, and so it has an NA value, and essentially saying I didn't use those values. So of all the penguins that are Adelie penguins, there are 2 rows it did not use because there were no values for it to plot. But in fact, this is not just all the Adelies, this isn't everything, because I just said use all the penguin data. So I need to be a bit smarter and tell R I only want to look at the Adelie data, and I'm doing so using changing, instead of saying just the whole penguins data set, I'm using the subset function to say I only want to subset this larger data frame, only using those cases where the species match the word Adelie. So it's very much, it has the same functional effect as we had here in the square brackets, but it's just a different way of doing it. Everything else is exactly the same. I hit enter, and now that figure looks different. Looks a little bit like we had before. You see the positions of things are slightly different because of the bins. There's a lot of differences in appearance that can be associated with bin choice, and that's sort of decisions that we sort of have to make. And again, now I just only have 1 individual that was missing, and again it says, pick a better value with bin width. So I think it's told me enough times that I should change my bin width, and what I'm going to do is I'm going to do that by writing within the geom histogram function. I'm going to change the argument and say, what would happen if I had bin width of 1? I don't really like that. So it's losing a lot of variation in it. We can try all different kinds of things. So let's say like 1. Not bad. Let's try 0.01. Yeah. I don't like this very much, especially because it is smaller than the smallest unit of measurement. And so it gives the impression there are sort of missing values between them, the missile possibilities. But the smallest resolution we have, the smallest precision we have with our instrument is like 0.1. So it gives us the illusion of sort of other things in there. So let's try like a 0.25. That's not bad. play around with it. Remember, when you're talking about changing the aesthetics of things, there is no right or wrong answer. I just want to see you make some effort. Think about things. Find what is appealing to you. What's appealing? You won't get penalized for having ugly choice of colors. Because just say something that which speaks to you. So there's a lot of sort of different sort of depths and stuff we can play with that. Now, what we do next? Well, one of the amazing things about Ggplot is there is a very extreme level of customization that we can make on all the different elements that you see on the graph. We can start off with focusing on this histogram. We can change. Here's the the bin width color. Let's try 0.5, and I can change not only the outside borders of each one of the boxes of those bins, but also the inside of them. So this is what it would look like if I use 0.5 millimeter bins with a white inside and a black in a pink outside. That looks all right. Maybe that's not you. Here's green and yellow. It's a little gaudy, but I think we can live with that for today. Again, sort of find something like that. There are tons of different colors in there. You can download all different kinds of color palettes as well. But there are lots of sort of default colors in R. You can also put in like hex codes. There's all kinds of things you can do here. So there's infinitely customizable. Now, one thing I might want to do is maybe I want to say well, where is the location of the mean? This. Maybe I want to say, what is the build out? Make it easier for my audience to understand where my mean of my sample is. Well, I could use the function penguin bill depth subsetting just for the delis. I hit enter. I get an NA value, and the reason I get NA is that because the default settings of the mean function don't know what to do if you went into a missing value, an NA value, like we had up here. It freaks out. It doesn't calculate anything. So I need to make sure that I've added my argument na.rm, which is NA remove, is equal true. In that case, then it's 18.364. Now, I can then sort of add that into my plot, and I can do so adding a different kind of geom called a geom v-line. And I've made this maybe a little unnecessarily complicated by adding into within this geom v-line instead of just everything from sort of mean here, all of that essentially is 18.36. So I say I want to add in a v-line. What do I want to add in? My AES is I want to add the x-intercept is a v-line, a vertical line. The AES saying what I want to add in. The x-intercept is going to be at 18.34636. And I want to give it the color blue. There's different line types and different sizes of those lines. And again, this is the kind of thing, there are dozens of different types of lines you can choose from, lots of different sizes you can add in, lots of different colors. In this particular case, I've added this sort of bold dashed blue line in the middle that shows the location of the mean. Now, maybe I would like to also sort of, put in the 95% confidence intervals. And I can get those easily using my t-test function, which, here's my mean, here's my upper and lower confidence intervals. Don't worry about, all the rest of the things here. This just tells us essentially our 95% confidence intervals, our estimate of, or essentially our the variability associated with that estimate of the mean. So to make those extra lines, I'm going to add on additional geom v lines. So there's my original data, and I've added another geom in this case, I'm using substituting in x-intercept of the lower one, coloring it orange, giving it the 2-dashed line, and with size 0.75, and then the second one for the upper confidence interval, and there we have it. So I changed the bin width too on that one again, just to try things out. So again, sort of this is a little garish. You may not need to show this, you may not want to show this, but if you do, now you know how to do it. Now, there are lots of sort of different ways to sort of customize plots in R, but you may want to essentially not have to sort of worry too much about doing a little bit of everything, and you can download or use built-in themes, which essentially are a whole bunch of preset settings that will change the general appearance of your graph. So one of them is sort of theme BW, which I've just added on to the end of our sort of a basic graph. So everything is the same. I changed the bin width back to 0.5. I'm changed this to a red and yellow. And what you can see here is that it essentially has changed the appearance, the background, and the outer side. I'm not a huge fan of theme BW. The sort of the default setting is sort of theme gray for the background. There's theme test. Here's another one, and I like this one because it does remove a lot of that sort of unnecessary clutter. Some people like those sort of guidelines in the back. I don't particularly like them, so I kind of like theme test, and you can also make all kinds of sort of different sort of elements on it. Now, what else can we do in here? Well, we can start customizing the axis labels. So to do so, I'm going to add on another object called labs for labels, and this one I'm going to label both the x-axis and the y-axis. So again, making something meaningful. This is the build depth measured in millimeters, and the y is the number of Adelie penguins. And that sort of makes that look a little bit better. We can also sort of customize the limits of this particular graph. So I can add on changing the y limit. So I want to have my y-axis go from 0 to 30, my x-axis go from 18 to 24. I can add those values in. This is telling me, I removed 2 rows, 1 row containing non-finite values. That's what we've seen before. 2 rows containing missing values, things which are outside the range. Those are not big things to worry about, but you can sort of play around and customize this as much as you want. Now, what about the font? The fonts. By default, this has a basic sans serif fonts. You can load lots of fonts. You can see what kind of fonts you have. If you're on a Windows machine, you can use this function to call up the names of all the fonts that are preloaded into your computer. There's lots of other ones you can download and add. Quartz fonts, so these are the ones that are built in with R, and I haven't added any new ones in for now. But let's just say I want to change all my text on here. I'm going to now add on another element, which is a theme element, and so everything is the same, but now I have I'm going to change the theme, and the thing I want to change is the text, and I want to change all the text, element text, and change it to the family's Times New Roman and make it size 12. And that just made everything 12. But again, there's a huge amount of sort of customization that you can have, and I'm going to put up a figure right now that sort of shows all the different elements. It also will be sort of posted below if you want to change any one particular element of it. I'm going to show you just one that's kind of silly looking, that if I say really felt strongly that I needed to have the y-axis label in bold purple, in bold purple, that I can just add another theme on top of that, just changing axis title.y, which will just change that one particular one. And now I have that in purple. So you can change every single element. You can change the numbers. You can change pretty much everything you can see, everything you can imagine. The world is your oyster. Now, what do I do when I want to sort of get rid of this? Well, I can use the function called Ggsave, and you should check the help function on that. It tells you a lot of the different arguments if you want to sort of to change the resolution, the size, and things like that. By default, Ggsave will save essentially in the size of the window you have open, which may be good for you, but you may want to sort of change the different things. So I'm going to save this as a PNG, which is a nice sort of graphical file. You can save things as JPEGs and stuff like that as well, and GIFs, but PNGs are nice, sort of easy to work with. And I don't need to do much else besides say give it a title. Make sure what kind of file it's going to be, and you can see by default, you know, the settings and the pixels, the point size, the background's white. There's all kinds of different sort of things you can add onto there for you to sort of play around with if you want. But I'm just going to hit this. It's saving it as an image that is 3.27 times 3.27, I think, centimeters, and it saves the last figure you made, so you can sort of get everything right, and then hit Ggsave, and you're good to go. And that is saved to my working directory, and that's done. So that's pretty much everything I have for today. All these codes are going to be annotated, well, they're attached onto here, so you can play around with these, and yeah, have fun with it if you want. Otherwise, I will see you in our next video. Take care. Bye.